assuming you have picked your target and gone to it and centered it in your field of view. I guess this is a little out of order. Normally what you want to do is go to a bright star and focus on that, and then slew to your object. But we'll just talk about focusing here. So really great aid for focusing are these Bahtinov masks, and you can get them online, or there's different sizes given the specs of your telescope, so you'll see that. And this is a good graphic here of, it creates a diffraction pattern. So you see that X shape there, and then there's in this case a vertical line, and as you come in and out of focus, that vertical line shifts to the left and the right. And what you want to do is put that exactly in the center of the X, and that's when you're in focus. So again, go to a bright star, put your camera in live view if it's a DSLR, and then you can watch in real time as you turn the focuser. Put your Bahtinov mask on the end of the scope, dial it in, and then remove the Bahtinov mask, go back to imaging mode, and you're all set for the night for focus. Now, if there's going to be a big temperature shift over the period of time that you're focusing, you might want to go recheck your focus. I'm on the west coast, and the temperature doesn't change that much, so I don't worry about that too much. And my main scope is carbon fiber as well, so that reduces the amount of thermal. But as you advance in the hobby and get more serious about it, there's temperature sensor, motor controlled focusers that will keep things in focus, and there's also computer autofocus programs and whatnot. But this Bahtinov mask is a good way to get started. We talked a little bit about this subject, framing your object. Some of the planetarium programs, as I mentioned, let you do that. A really good tool that I like to use in planning is this New Astronomy Press CCD calculator. I think it's just called CCD Calc for short. And it has a whole list of telescopes in there. You can add your own, and it has a whole list of cameras, and you can add your own. And then by picking the telescope and the camera, and then on the right hand side you can pick a deep sky object, and then it will draw a box and give you an image of that deep sky object and tell you what your field of view is going to look like. So that's very handy for planning and seeing how large or small an object is in your field of view. And maybe you have different telescopes or focal reducers or different cameras or what, so you can then plan what combination of hardware that you have would be best for the particular object that you're interested in. So now we come to follow or tracking of your object. And so this has to do with deep sky imaging. We're typically using a German equatorial mount, so it's has the right ascension axis that it's gonna track with the stars. And how good that tracking is gonna determine how long of an exposure you can get away with without having any jagged stars or star trails or stars out of round. And as I mentioned earlier, it depends on a good polar alignment, or doing a drift alignment to get even closer to an accurate polar alignment is a good approach. And then short of actually auto-guiding, you can do what's called periodic error correction with your mount, where you figure out in advance where the inaccuracies are as the various gears and mechanical components inside your mount interact, and you make kind of a recording of that, a chart of that, and then you feed that back into either your mount does this in the handset, or if you're using a computer, hopefully the Escom driver will do that and make corrections for that as you go along. But the typical method used for, I'll call it consumer grade mounts less than $10,000 probably, is to auto guide. And that's where you have typically a separate telescope, maybe like a finder scope and camera that's connected to an auto guiding program like PhD2 that is going to keep track of a star's location and send corrections to the mount in real time to keep it tracking accurately with the objects. There's also what's called off-axis guiding, where instead of a separate scope, you have a little pick-off prism or something in your optical train for your main camera that then goes to a second camera, and that has some advantages and disadvantages. The advantages are that there's no what's called differential flexure. There's no separate scope, so there's no separate optical train that might be moving relative to your main optical train because of temperature variation or vibrations or whatever. The downside of off-axis guiding is you've just got that tiny little pick-off prism or mirror that's just in a little piece of your imaging circle. So there's going to be fewer guide stars and a smaller field of view, and maybe not access to bright guide stars. I'm going to recommend that you probably should start out with a separate, inexpensive guide scope before trying to do off-axis guiding. So again, this is some more detail, and the rig on the left is a typical starter auto guiding, and it works quite well. The Starshoot auto guider camera and the little auto guide scope that Orion, I think, has 3 different versions of these now. There's a new one that's a larger size, might be a better approach if you've got a longer focal length on your main scope. But anyway, those are ways to start. And then you see a more advanced setup on the right there, where they've got a larger telescope being used for the guiding. And there's 2 methods then of communicating between your auto guider and your mount. One is this ST4 cable. It's the little telephone cable connection that you see on the left of the image. On the left connects to your camera with your computer with the USB cable that's on the right of the camera. And then there's this ST4 jack on the left, which you can connect directly to your mount. That's quick and easy, but there's another way to do it if you're driving your mount with Escom software. Escom is a standard for how Windows astronomy software and hardware communicate with each other. So if you're driving your mount with Escom, you can eliminate this ST4 cable and do what's called Escom pulse guiding. And that has a couple advantages. The main one being that your auto guiding program like PhD2 is going to know where in the sky your scope is pointing, and that lets it do better optimizations and adjustments as you move around the sky. And it's also said to be more accurate in terms of the width of the pulses and all that it sends to control them out. So I recommend Escom pulse guiding if you can do that. Okay, so this talks about basically what I was just describing, the ST4 port, but better if you can use Escom. And on the left at the bottom, there's a picture of an off-axis guider adapter, and you can see that little pick-off prism there that sticks down into your image circle. And there's some controls for sliding that back and forth to try to find guide stars. For starting out anyway, I recommend just a separate guide scope.